Okay, for this one, it's pretty much the same as your exponential graph, in the sense that you have Q for horizontal asymptote as a restriction of your graph, and you also have an additional asymptote, which is vertical asymptote restriction of your graph as well. By this P, it's just restricting your graph to not touch that line represented by P in this case. Okay, on the x-axis, as you can see, x plus P. Okay, what about A? What is the use of A in this case? A would be for direction as well. Okay, if A is positive, it means that your graph would be given the asymptote. Let's say there's an asymptote. Okay, let's say there's an asymptote. Your graph would be on the first quadrant and the third quadrant if your A is positive. What about the case where the A is negative? It's gonna be on the second quadrant and fourth quadrant. That's pretty much the use of A. It's just that you would never have a situation where you have negative here and your graph is lying on the second quadrant and fourth quadrant. That means you are wrong. All right. Okay, so that's pretty much the use of A. What about Y? Y is just for y-intercept. It's just for y-intercept, where you will let your x be 0, then you get your y-intercept. What about x? Your x is just for x-intercept as well, where you will let your y be 0 and determine your value of x. Okay, same thing even here. Y is just for y-intercept, where you let your x be 0 here and you get the value of y-intercept. What about x? X is pretty much the same as x-intercept. It's just standing for x-intercept, where you let y be 0, then determine x-intercept. Okay, where appropriate, of which in most cases you won't have x-intercept. Okay, let's give ourselves an example here. Let's give ourselves an example. Let's say you have y equals to 2, x is x, plus p being 2, plus, let me make this be plus 1. All right. So this means that our horizontal asymptote is 1, because 2 is 1. Our horizontal asymptote is 1. Okay, so you can draw those dotted line here. That is our horizontal asymptote. But for this one, we have 2 asymptotes. What about this one? If this value here is positive, our horizontal asymptote, vertical asymptote, will be negative. If this value here is negative, our vertical asymptote would be positive. In this case, it is positive. Here is going to be negative. Okay, negative 2. So our vertical asymptote will be here. Okay, that is our vertical asymptote at 2. Alright, so what we know that our graph is gonna move here. This is the third quadrant, and this is the first quadrant, and this is the third quadrant. Do you see, if we're gonna cut y here, meaning we do have y-intercept, because we're gonna cut y here. What about here, the third position, third quadrant? We're also gonna cut x here, because it's gonna move here and it's gonna cut this graph here. So we also have x-intercept here, which is the value that is less than or negative 2. It might be negative 3, I don't know. We're gonna calculate that. You see, that's how we interpret this. Okay, let's go and find the y-intercept first. Y-intercept is given by 2 divided by 0 here, plus 2 plus 1. 0 plus 2 is just 2. 2 divided by 2 is 2. It's 1. 1 plus 1 is gonna be 2. Okay, so we have 2 here. Okay, we can work this out at a long way. It's fine. So we're gonna cut at this point. Let's say for simplicity purpose our y-intercept is here, so we can draw a graph like here, like this, and move closer and closer to the vertical asymptote, but it won't touch asymptote. Right, that's our graph, the first part of the graph. What about the second part or second curve of the graph? We're gonna cut x here, so we need to know what the x to cut here. All right, for x, y should be 0. 0 equals to 2 divided by x plus 2 plus 1. Okay, mathematical, you can, or algebraical, you can just take this one to the side. All right. Okay, so this negative here equals to this side as it is. All right. Those who have done physics would agree that we can simply take this minus 1 to the denominator and take this part to here, interchange this. All right, so in that case we would have x plus 1 equals to 2 divided by minus 1. You can do either way, or you can just cross multiply. I'm just doing the simple way. All right. Okay, so we have x plus 1 equals to minus 2, because 2 divided by minus 1 is minus 2. All right, then you cross this to that side. As we estimated, our x-intercept is now at negative 3. Okay, so our graph has to cut here and move closer and closer to the asymptote, but would never touch the asymptote, and we are done. Okay, so that is our graph. They can ask you to determine, let's say this is point A and this is point B. They can ask you to determine the distance between here and here. What you have to do is to use a distance formula, because at this point you have 0 and 2, to this point you have negative 3 and 0, so you can use a distance formula here. All right. I think I'm done here. If this graph were to be here, obvious, somehow, if we can take that graph to here, somehow it would cut this graph and this graph. So you might be asked the coordinate of the point where these guys meet, right, or cut each other. In that case, you would say this graph at that point share equal value as this graph, meaning if this graph is g of x and this is f of x, it will mean that g of x where they cut each other is equal to f of x, and g of x is given by 2 times 2 to the power x plus 3 equals to this graph, which is f of x. Where is the equation of this graph? Is this one, equals to this. Then you simply solve for x here. If this was to be the case, you simply solve for x and then take the x value to substitute into any of these equations to get the corresponding y value, right? If this was to be the case. Okay, the question would be, what could be the domain, since there are restrictions here? What could be the domain and range? Domain of here, because the graph is moving infinite to the negative side of x, so we already have negative infinite as our domain, and positive infinite because the graph is moving forever to the positive side, positive infinite, positive infinite, or one would say x is an element of all real numbers. But for the purpose of range, looking at the y direction, this graph is only limited here. It would never come down past 3. All right, so we would simply say the range is that. All right, but in this case, do you see if at this point for y, let's focus at x. We cut the graph here at the value of x at this point. We can cut all the values here of x. You see, we can cut all the values of it, but this graph will never cut this point. For x purpose, would never cut this point, but this graph is all over here, up to close to -2. Even on the negative side, beyond -2, you would find this graph. Before the -2, you find this graph. What does that mean? It means that this graph only excludes -2 in case of x. So the domain will be simply x is an element of all real numbers where x is not equal to -2, because -2 is excluded. Same thing even y. This graph will never cut this one for y-intercept, will never cut the horizontal asymptote, meaning y is an element of all real numbers where y is not equal to 1, because this asymptote, which is horizontal asymptote, is excluded here. All right.